So our final gas law, Gay-Lussac's gas law, the relationship of pressure and temperature. If we remember, our formula for that is right here. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. Let's go ahead and bring that in here so that we can see that as we're working through our problems. It's going to be important. We'll just set it down here in the corner. Let's work through some of these problems and see how well you do. You should work these out first, then come back and check your work on the video. So if glass in a closed container is pressurized from 15 atm, so that's going to be pressure 1, to 16 atm, so it's increasing in pressure, so that's going to be pressure 2, and the original temperature is 25 degrees Celsius, so that's temperature 1, what would the final temperature of the gas be? So we are going to solve for temperature. We're going to solve for T2. We don't know what T2 is. First, let's convert 25 degrees Celsius into Kelvin. To do that, we do 25 plus 273 because we always need to be in Kelvin. So 273 plus 25 is going to equal 298 Kelvin. Right there. And then we are good to go. We're good to set up our problem right here because we already have our atmosphere units for pressure, so we don't need to do any conversion. So our pressure 1 is 15. Sorry, I should put ATM right there, 15 ATM. Our pressure 2 is 16 ATM. Our temperature 1 is 298 Kelvin. And we are solving for temperature 2. So that is a nice setup for us right there. We will just cross multiply and we will solve. So here and here. So you get 15x equals 298 times 16, which is going to be 4, 7, 6, 8 right there. And then we just divide by 15 on both sides. So divide by 15 here and divide by 15 here. Divide by 15. My answer comes out to be 317.9. 317.9, but we're going to go to 3 sig figs, so we'll just go to 318. 18. And we're looking for final temperature, so that's going to be measured in Kelvin. So let's see if that matches our law. That's our final answer, is 318 Kelvin. When we were looking at this, the pressure increased from 15 to 16. Did our temperature increase? Yes, it did. It increased from 298 to 318, so that's following our law. Okay, let's look here to our next question. Let's identify the important aspects of what we are doing first. So we have, if a gas is cooled from 323 Kelvin to 273 Kelvin, so that's our T1 and T2. Whoops, delete that. That's our T1 and our T2 there really quick. T1 and T2 right here. Very nice. What would the final pressure be if the initial pressure was 750? So that's going to be our P1 right there. So first, let's convert. Is there anything we need to convert? Kelvin? No, it's already in Kelvin. We're good. We do need to convert that to ATM. So we do 750 divided by 760 because there's 760 millimeters of mercury in 1 ATM. So 750 divided by 760 is going to give me 0.98, actually rounded 0.99 ATM. And that is, again, our pressure 1. So let's set up our problem. Pressure 1 is 0.99 ATM. Pressure 2, we don't know. We're looking for our final pressure, so that's going to be X. Temperature 1, 323. Temperature 2, 273. Both measured in Kelvin. And then we will, of course, set it up and cross multiply once again, because that's what we do. Right there. We end up with 323x equals, and then 0.99 multiplied by 273. 269. 269 right there, and then we will just simply divide by 323 on both sides. So divide by 3, 2, 3, and then divide by 3, 2, 3. Just like that. Sorry for the poor handwriting. The struggle is real when writing with this program. So we got 269 divided by 323. End up with 0.83. X equals 0.83. And what were we measuring in? What would be the final pressure? So it would be 0.83 ATM. Does that match our law? We decrease the temperature, What happened to our pressure? It decreased from 0.99 to 0.83. So that was a major improvement, followed our law perfectly by decreasing. Excellent job, success. Let's quickly do numbers 3 and 4. First, let's bring in our formula right here. Gonna have to extend the page a little bit here to bring in the formula. Scroll up. Okay, we are scuba diving. Scuba diving with some friends here. The pressure in the scuba tank initially is 130 atm, so that's going to be our P1. The surface temperature is 25 degrees Celsius, so that's going to be our T1. The temperature increases in the ocean to 45 degrees Celsius, so that's going to be our T2, and we are solving for ATM or P2. So we have our P1, which is 130 ATM. We do not know our P2, that is X. Our T1 would be 25 plus 273 to get to Kelvin. Going through this one a little bit quicker, so that'd be 298 Kelvin. And then our T2 would be 45 plus 273. Oh, I did times 273. That's not right. Plus 273 plus 316 Kelvin. There we go. And then we just cross multiply and solve. We're going to go through this quickly because you've seen a few examples so far. So you end up with 298x equals, this is going to be a big number, 130 multiplied by 316, 130, 41,080. Divide both sides by 298, divide by 298 on both sides. We end up with x equaling, divided by 298. X is going to come out at 138. That's rounded up. 138 atmospheres because we are measuring in pressure. So that right there is going to be our final answer. Let's check our work. We started off with 130 ATM and 298 Kelvin. The temperature increased to 316 Kelvin. Therefore, according to our law, the pressure should also increase, and it did. Success, which would make sense because in the ocean the pressure increases. Here we go. Number 4, last one. Tanker truck carrying pressurized oxygen from Minnesota to California. Long drive, but Minnesota would be much better to go to California. Temperature in Minnesota, negative 12 degrees Celsius, which is why California is better. When it arrives in California, the temperature is 40 degrees Celsius. So right there, we have our T1 up here and our T2 right here. If the initial pressure was 891 millimeters mercury, what is the pressure arriving in California? So we are again solving for P2. That is what we are solving for. Let's do our conversions that we need to do. We got to convert two things into Kelvin. So our T1 is negative 12 plus 273, negative 12 plus 273. So in Kelvin, that's 261 Kelvin. Our T2 equals 40 plus 273. So it's going to be 313 Kelvin. Our pressure 1, we have to do 891 divided by 760 because there's 760 millimeters of mercury in 1 ATM. So 891 divided by 760. And that's going to equal 1.17 ATM. Okay, so now we have everything we need. We can go ahead and we can set it up. Extend this just a little bit. So our pressure 1 is 1.71 ATM. Our pressure 2 we do not know. Our temperature 1 is 261 Kelvin. And our temperature 2 is 313 Kelvin. So we're going to set up our ratio here. Right there. Right there. Cross multiply. So you get 261x. 261x equals, we got to do 313 multiplied by 1 point. That's supposed to be 17. That's my fault. 1.17 equals 366. Right there, and then we will just divide each side by 261. Divided by 261. Divided by 261 right there. 261. So 366 divided by 261. X equals 1.40. And that is our new pressure, 1.40 ATM. So what happened when we increased the temperature significantly from negative 12 to 40 in Celsius, or from 261 to 313 in Kelvin, we increased the pressure from 1.17 all the way to 1.40. Let's go back just to prevent any confusion. That right there should have been, I typed that wrong. It should be 1.17. There we go. So that would be our final answer right there, and it follows the law. So there's some Gay-Lussacs Law Practice problems. Hopefully you found some success, and we'll move forward from here. Farewell.